Hello everyone. So today we are solving another LeetCode problem, that is the 69th problem, square root of x. So this is the difficulty level of this problem is easy. So as the name itself says, we have to find the square root of a given integer number. So I'll read the question first and then look into the code. Given a non-negative integer x, return the square root of x for a non-negative integer and round it down to the nearest integer. So we have to round off because if x is equal to 8, then square root of 8 is 2.82842. So they have given it here. We'll be rounding off to the nearest integer, that is 2. The returned integer should be a non-negative integer as well. You must not use any built-in function. So there is already an inbuilt function, that is Sqrt, of in the brackets the integer value what we sent. So that built-in function should not be used. That is the reason they have given it here as my square root, because square root already exists. And another example they have given here is if x is equal to 4, then the output should be 2. And the constraint is the only constraint, that is the value of x will be varied from 0 to t to the power 31 minus 1. So that's it. They've given the example for this inbuilt functions, that is power or double asterisk, that returns the exponential value, but we have to write everything ourselves. So let's look into the code now. The brute force approach will be like, first we'll look into brute force and then the optimized approach. So in the brute force approach, we'll have one variable I that we will initialize it to 1, and then we'll write a while loop where I runs from 1 to, because 1 is initialized, to less than or equal to x divided by I, and we have to increment I, and we'll return I minus 1. So the brute force approach is only this much, but why is this called brute force approach? Is for every value of I, it will be checking, and I will be incremented in every step, that is inside the while loop. But in the optimized approach, we'll use a similar kind of binary search um, approach, because we'll be finding the mid value and then we'll decide we have to go to the right side or to the left side. That will reduce the number of iterations the code takes. So this code might look small or lesser number of lines in this, but when we look at the time complexity, this will take more time than the optimized approach we'll be looking into later. So I'll run this first and we'll check the test results. So it is accepted and we can submit it here once we're done. But now I'll be writing the code for the optimized approach and then we'll submit. So in the optimized approach, again we'll be taking low 1, high x, and answer 0. So low is initialized to 1, high is initialized to x, whatever the number they give, and answer is the variable that is used to keep the final result. So we'll run a while loop here also. When low is less than or equal to high, we will find the mid value, that is low plus high minus low divided by 2. So if this mid value is less than or equal to x divided by mid, then we will keep that mid value in the variable answer, and we'll go to the right side, that is looking for any other higher value exists for this or not. So we'll be going to the right and checking that. Otherwise, else we'll go to the left side of the mid value, that is mid minus 1, and then we'll be returning the answer. So this is the optimized approach for square root of x, because we'll first find the mid value and then we'll decide whether to go to the right or left. So that like it literally reduces half of the iterations that the brute force approach would take. So this will run and see. So it is accepted. Both the test cases are accepted, and here we can submit. And now we'll be looking into the tracing of this, how this code exactly works with a example, that is x is equal to 8 or x is equal to 4. So let us look into the tracing now.
We'll take the example as x is equal to 8. So square root of 8 is 2.82 something, but which is rounded off to 2. We'll write it as a tabular column. We had variables low, high, mid value, and mid should be less than or equal to x divided by mid. So this is the condition and these three variables. Initially low was 1, high was x, high is equal to x, that is 8 here, and mid is, we have to calculate the mid now. So the mid value is calculated as 1 plus 8 divided by 2, that is 9 divided by 2 is 4.5, which is taken as 4. Mid value is 4. 4 is less than or equal to x divided by 4. So this is 2 and this is not equal. So we'll be moving to the left side. Because this is a huge value, we have to search in the left side, not if we go to the right side, it will be even higher values. So we'll come from lower values now. So while going to the left, the high is modified, while going to the right, low is modified. So now we have to make high as mid minus 1. So mid is 4, mid minus 1 becomes 3, that is high value, and the low remains same. So if low is 1, high is 3, the mid value will be 2, that is 1 plus 3 divided by 2 is 2, mid value 2, and mid value is less than or equal to x divided by mid, that is 2. So 4, 2 is less than or equal to 4. So this satisfies, and we'll be making answer as 2, and we'll again search in the right side. If we get any other value higher than this, we'll make low as mid plus 1. So low becomes 3, and high is already 3. So even now this condition satisfied. The while loop condition where we wrote low should be less than or equal to high, this is satisfying because 3 is equal to 3. Mid value now becomes 3. 3 plus 3 divided by 2. So this becomes 3, and 3 should be less than or equal to x divided by mid. So this condition does not satisfy because 8 divided by 3 will be 2.6, wherein this is rounded off to 2.6, and 3 is not less than or equal to. So this condition does not satisfy, and again when this is incremented, this condition will not be satisfied. So let us do that step also. When this is not satisfied, we have to search in the left part again. So we'll make high as mid minus 1. So mid minus 1 will be 2 and this will be 3. So 3 is not less than or equal to. So if this condition only does not hold good, then it comes out of the while loop. So the while loop is broken. So there it ends, and after the while loop we have written answer. So this is the answer we got, so that will be written here. So square root of 8 is equal to